Hello! Yes, I am on my holidays and it's incredibly hot, so I'm going to keep this one quick and simple. Let's make Snake. And of course I am talking classic retro Snake running here in the console. So you can see I've got a Snake here and I am steering him from the Snake's perspective, which could be quite a controversial way to do Snake. I remember this from the Nokia phones. And of course the Snake grows as we pick up food and we accumulate a score. And if the Snake hits the wall or himself, that is the end of the game. And we can see the Snake turns into a skeleton and we have to press space to play again. Excellent, let's see how this is done. It's not very many lines of code. Now because I'm working from my portable man cave today, I'm afraid we don't have as many luxuries as we usually do, so I'm filming in a slightly lower resolution and of course I don't have my voiceover microphone. However, Snake is so simple I don't believe we need any of that to get the point across. Now if you've watched my videos you'll know how my console programs go by now. The first thing we do is create a standard blank console program. And then we'll want to add a screen buffer to it using the create console screen buffer. I'll make sure there's some little tabs somewhere around here. You can click on those and have a look at some of my other videos which show exactly how this code works and what it does. And of course we'll want to store the screen width and screen height. Now I'm using 120 by 80. I'm just going to bin off the output here so we've got more screen to look at the code, and I'm going to create a simple game loop. And as usual, all my game loop does is display the screen buffer to the screen using the right console output character. And like all my simple console games, we can break it down into 3 stages. The first is timing and input. The second is the game logic. And the third is display stuff to the player. I've decided fundamentally our Snake is going to be a linked list. This means I'm not going to have a 2D array anywhere storing where the Snake segments are. So I need a structure which represents a Snake segment to store in our list, and this is very simply going to be an X and Y. Alternatively, I could store the positions of the Snake's head and the Snake tail, and as the head moves along each time, the tail also moves along. And I maintain some sort of history of how the tail should follow the head. I think this might get a little bit complicated. So instead, I'm just going to have a linked list where each element in the list is a segment of the Snake's body. And we'll see why this has some advantages later on. So each segment is just going to be a simple struct containing an X and Y parameter. And therefore we can create a linked list object to store our Snake. However, the Snake needs some sort of default state. I'm going to use the static initializer lists, which are much improved now in Modern C. So for each element of the Snake, I'm going to store some coordinates, and my Snake is going to start at 60, 15, which is the 60th column across and 15th row down on the console. And that's going to be the first segment, and then I'm going to store the second segment now, 61, 15. And I'm going to keep doing this all the way until I've got 10 segments of Snake, all in a line horizontally on the screen. There we go, excellent. I'm going to need some game state variables too. So very simply, I'm going to have the location of where the food is, food X and Y. I'm going to maintain a score. I'm going to keep a variable which is Snake direction. And this is going to be for the compass points. So 0 will be pointing up, 1 will be pointing east, 2 is south, and 3 is west, compass points. So the Snake is going to start off heading west. And finally I'm going to have a boolean for be dead. This will be the end of game condition. Unusually we're going to work backwards this time. I'm going to start with the presentation. Of course somebody is doing works right outside, right when I decide to start filming. Let's just see if it's going to take very long. So each frame of game update, the first thing I want to do is clear the screen. I'm doing this by simply drawing a space to every element of the screen buffer. I'm then going to draw some furniture onto the screen. So this is things like some shameless self-promotion here, and the title of the game and the player's current score. This will also put a little boundary at the top of the screen. The next thing, of course, is to draw the snake, and this is quite easy with the auto keyword because the snake is a linked list. All we do is iterate through the list, taking the coordinates of each body segment and drawing it accordingly. Now in this case I'm using the BDEAD flag to draw either the skeleton, which is going to be the plus symbol, or a segment of the snake's body, which is going to be a capital O. In a very similar style I'm going to draw the snake's head. For this I just take the front element of the linked list using the front method here, and that will give me the X and Y coordinates, and in a similar way I use the BDEAD variable to tell me should it be a capital X for when the snake is dead, or should it be the @ symbol for when the snake is alive. And drawing the food couldn't be simpler. We take the food X and Y coordinates, translate them, as we've done with all of these drawing methods, from a two-dimensional coordinate system into a one-dimensional for the screen buffer, and I'm going to use the % to indicate food. Let's take a quick look at this and see if it's working. Excellent, so it's compiled. We can see at the top here we've got the border including the shameless self-promotion and the score, and we've got a snake with a head and an element of food. Perfect. Sometimes getting the presentation out of the way early is the correct thing to do, because we can make little changes to the game logic now and immediately see the results. There's only two controls in this game, the left key and the right key. So I'm creating some booleans here which will store the left key and the right key and the previous state of the left key and the right key. I'm storing the previous states because I only want to acknowledge the input on the change of the input, so I'll first of all compare the old state versus the new state, but I also only want to look at when the key is pressed, so I need this temporal information in order to make this decision. This can be considered a latching behaviour. The user will press the key, but it will only send one event. We're not going to continuously send events per frame whilst the key is held, and this will stop the snake from coiling up and hitting itself immediately as soon as the player presses an arrow key. Like all of my other console applications, I like to make liberal use of the getAsyncKeyState keyword. So this will retrieve the immediate state of the left and right arrow keys. These are the codes for it here. And these are the conditions I've just talked about, so only in the condition of the key has been pressed for the right key increments the snake's direction, and for the left key we will decrement the snake direction. I've added some little clauses here to make sure that the snake direction wraps round, so it's always between 0, 1, 2 or 3. And like Tetris, I don't want the game to run at the full throttle of the CPU. Instead, I need it to slow down a little bit just to make it possible for the player to actually acknowledge what's going on. If we didn't do this, the snake would just shoot straight off the screen. Rather crudely, I'm doing this with a hard delay. Now we've dealt with presentation and input, we can do the fun stuff, the game logic. Let's start by making the snake move. Remember that my snake is just a linked list, so to make it move, I push something into the head of the snake and I pop the tail, and all of the snake will appear to move one along. The tricky part is working out what coordinates to give the snake's head when you push the new head onto it. So here I'm using the push front command, and if the snake is going in the up direction, I want to take 1 from the Y coordinate of the current front of the snake. And you can see here I'm using the initializer list as an argument to keep the code concise. Exactly the same is done for the down, except instead of -1 from the Y, it's +1 from the Y. And as you might expect, for right and left, we affect things in the x-axis instead. So that's adding the new head in the new head position depending on where the snake is going. And of course, at some point, we're going to have to chop off the snake's tail, and this is simply popping the last element of the linked list. Let's see what happens now. So we can see the snake scrolling along the screen. Of course, we've not done any collision detection yet, so I don't expect anything to happen with the food. And if I press the right key, and again, and again, and again, the snake turns right. If I press the left key, the snake turns left. Excellent. So let's add in some collision detection now. The first thing we're going to check for is snake versus world. So this is where we're checking if the head of the snake, which remember is always the front of the linked list, is within the boundaries that we've defined as being the gaming area. In this case, in the x-axis it's just between 0 and the screen width, so it's the whole width of the console, and for the y-axis it's between 3 and the screen height, and that's because I've got the border and information at the top of the screen. I don't want to allow the snake to go on top of that information. And if the snake does violate any of these conditions, we set our dead flag to true. And we'll do something with the dead flag later, but as you already know, for the presentation, this will change how the snake looks. The second thing the snake can collide with is, of course, the food. And this is a good thing. It's easy to check for because all we're looking for is whether the front of the linked list, i.e. the snake's head, equals the same coordinates as where we've decided the food should be. And in that event, we increase our score by 1 and we want to place some new food. And this is where we have to think a little bit about the game design here. We can't just randomly choose anywhere to put the food, because if we put it inside the snake's body, well, I guess there's a philosophical debate here as to whether the game is relevant at all, but if this food is already inside the snake's body, the player can definitely not pick it up. So that's very unfair to the player. Instead, what I've chosen to do here is to randomly choose coordinates, and when the coordinates are valid, i.e. they are not somewhere that's already defined using the screen buffer, so as long as the screen buffer contains an empty space at that coordinate, then we're okay. You might think it's a bit cheating to use the screen buffer as a memory storage device, but indeed, why not? If there is blank space there, then we can accept that the randomly generated coordinates are valid. This is one of those scenarios where thinking about the early game, it doesn't really seem to make much sense. But if you can imagine a player that's been playing for 5 or 6 minutes or so and has a very long snake now, that placing the food inside the snake would be very unfair to the player. I guess one solution is we could always put the food where the snake had last been, because we know that its tail will leave an empty space. Of course, this would look like the snake is going to be eating its own feces and probably doesn't make a very clever game, because later on, when the snake is many loops, we're probably guaranteeing that we're putting the food in a space that the snake can never access. Regardless, whatever the approach of choosing where to put the food, the next thing we need to do is grow the snake, and because it's a linked list, all I'm going to do is duplicate the tail by another 5 segments. It doesn't matter whether the tail segments overlap each other or not, it's a linked list. The system doesn't care and no information is lost. And as a byproduct, we also get the nice aesthetic that the snake grows. And of course, the final collision to detect for is the snake versus itself. Now, we only need to check the head position of the snake, and we need to see if it is overlapping any of the other snake segments. In this instance, I've chosen not to use the auto keyword because I need access to the actual iterator. So going old school for a moment and just manually entering the auto keyword with this highlighted code here, that's effectively all auto gets resolved to. I check each snake body segment here, which is the coordinates I, X and I, Y, with the snake's head. And if the head has the same coordinates as any of the body segments, then we set BDEAD equals to true. Now you may have noticed this at the front here. Of course, I don't want to check the head against itself because that will always return true. And it would be a very short game. And one of the nice things about C is when you do an if statement, these conditions are evaluated in order so we can quickly reject things. Let's do some testing. So the first thing to test is the snake hitting some food. What we should see is the snake growing. It does, and the score has increased by 1. We'll now run the snake into a wall. Oh dear, well we saw the snake turned into a skeleton, but of course the game didn't stop. And that's because we don't do anything with our BDEAD variable. Let's add that in. In the event of snake death, I want to display a message on the screen that says press space to play again. So I've just chosen the coordinates of my screen buffer and I'm using the printf command to do that very tidily for me. I'm also going to change our main while loop to exit on the event of BDEAD being true. So in normal situations, our BDEAD is false. This leaves me with a strange situation. We're going to exit our main game loop, which is never going to be a good thing. So I'm going to wrap that up in a secondary loop. Let's go to the end here, find the end, there we go. And so when the inner loop terminates on the event of BDEAD becoming true, I'm going to sit in a very tight while loop just waiting for the user to press the spacebar. Which again I'm using get async key state in order to do. And it's 32, which in hex is 20. Now this has a nice advantage that when the user does press the spacebar, we go back round to our main loop and we reset the game to a completely known state. It's always good in programming to be able to, at any point, get to a known state. Let's try again with our testing. So this time, I'm going to crash the snake into the wall. Excellent. Press space to play again. I will. And we'll try and crash the snake into itself. There we go. Press space to play again. But I've noticed something a bit strange here. I can't get the snake to double back on itself. I also feel the game isn't very well balanced in terms of the speed of the snake. Both of these problems are because of the way that we're putting a fixed delay inside our main game loop. This delay effectively stops the game. So I'm not capturing all of the input that the player is putting in. In fact, if I'm waiting 200 milliseconds per frame, that could be quite a lot of inputs that the player has tried to put in and the game is completely ignored. Having a hard and fast delay like this is causing us problems, so I'm just going to comment that out for the time being. And what I want to do is, instead of delaying one chunk, I'm going to sit in a tighter loop for a fixed amount of time, but I'm going to acknowledge any key presses that occur. In that way I can update the snake's direction, and hopefully we can get the snake to double back on itself, which I think is going to be very important for the player in the later stages of the game. To do this, I'm going to use the Chrono library, so it gets very wordy. Here we go. And whilst I'm basically creating a time point here, t1, getting the immediate time, and the condition for my while loop is going to be that a duration created by subtracting the current time by the one that I've stored is less than 200 milliseconds, with an excess bracket there. So all of my input is now handled within this loop, and this loop will only run whilst the duration is less than 200 milliseconds. Let's see if that makes the snake easier to control. Well, the snake does look like it's controlling normally, and if I rapidly double tap, I can get the snake to immediately go back on itself. And of course, if I rapidly triple tap, the snake will completely crush into itself. That's okay. I think this rewards the player with being precise with their inputs. There is one final thing which I think the player might be a little bit wary of, and that is the game is harder when the snake is moving up and down rather than left and right, because of the aspect ratio of the command prompt. We can see that moving vertically, the snake moves much faster. This gives the player the perception of having less time to make a decision. We can address this by changing the delay based on whether the player is moving vertically or horizontally, and this bit of code does exactly that. If the snake direction is odd, i.e. it is going west or east, when we modulate that with 2, we'll end up with a 1 as a remainder. So we want to use a shorter delay. In this case we're going to use 120 milliseconds. However, if this condition is false, the snake must be moving vertically. So we want to use a slightly larger delay. And in this case, that's 200 milliseconds. Let's see how that feels. Well, it probably needs a little fine-tuning, but it does feel a lot more balanced. And a quick little errata here, I've set the screen height inadvertently to 80 here. In fact, it's actually 30 on my console. And I only noticed this because food was generating, and of course I couldn't see where it was generating. Anyway, that's now fixed. The food should always appear on the screen. And so there you have it, a very simple yet feature-complete version of Snake, in under 150 lines of code. If you've enjoyed this video, please check out my others programming other types of games and all sorts of utilities and applications. Give us a thumbs up and have a think about subscribing. As always, the code is available on GitHub and you can follow me on Twitter at JavidX9, and I'm going to leave you this week with a little holiday movie. See you next time. Hello. Perhaps the world's oldest computer behind me there. Its operating system is simply the interpretation of an ancient race of the heavens. Its processor is the mechanics and physics of the universe. And it probably runs JavaScript.